Okay, anyone reply me? Screen is visible?
Yes, sir.
Okay, so all of you write down the syllabus for unit number 1. Write down section 1. In that we have to write down the unit number 1. Unit number 1, conduction. Unit number 1, conduction. So we have to write down the first sub point in that, modes of heat transfer. So all of you write down modes of heat transfer. Okay, today we have started the unit number 1. So before going to unit number 1, we have to write down the syllabus. So in that we have to write down the sub point. First sub point, that is modes of heat transfer. Modes of heat transfer. So in that write down the syllabus. Modes of heat transfer, first point. Modes of heat transfer. Modes of heat transfer. Then basic laws of heat transfer. 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 Then thermal conductivity and its variation with temperature. Thermal conductivity. Thermal conductivity and its variation with temperature. Thermal conductivity and its variation for for various engineering materials. For various engineering materials. Various engineering materials. So this is about the first sub point, that is modes of heat transfer. Then we have to write down second sub point, steady state heat conduction. Write down steady state
Hello.
heat conduction. Hello. Steady state heat conduction. Okay, anyone reply me? Sound is audible and screen is visible.
Yes, sir.
Okay. So write down second sub point in unit number 1, steady state heat conduction. Steady state heat conduction. Steady state heat conduction. Write down in that derivation of generalized heat conduction equation. Derivation of generalized heat conduction equation. Generalized heat conduction equation in Cartesian coordinates. In Cartesian coordinate. In Cartesian coordinate. In Cartesian coordinate and its reduction to and its reduction to Fourier. Fourier, comma Laplace and Poisson's equations. Fourier, comma Laplace and Poisson's equation. And Poisson's equations. Poisson's equation. Poisson's equations. Full stop. Next, generalized heat conduction equation in generalized heat conduction equation in cylindrical and spherical coordinates. Generalized heat conduction equation. Generalized heat conduction equation in in cylindrical and spherical coordinates. Cylindrical and coordinates spherical coordinates, in bracket no derivation. Cylindrical and spherical coordinates in bracket no derivation and its reduction to and its reduction to and its reduction to one dimension. Reduction to one dimension. one dimension, reduction to one dimension. Next, heat conduction through plane wall, heat conduction through plane wall, heat conduction through plane wall, comma cylinder, plane wall, comma cylinder, comma sphere, sphere, comma composites, 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 full stop. Then write down critical radius of insulation for cylinder and sphere, critical radius of insulation, critical radius of insulation for cylinder and sphere, for cylinder and sphere, cylinder and sphere, full stop, cylinder and sphere, full stop. One dimensional steady state heat conduction, one dimensional steady state heat conduction with one dimensional steady state heat conduction uniform with uniform heat generation for for wall and cylinder, for wall and cylinder, for wall and cylinder, in bracket numerical treatment, in bracket numerical treatment, numerical treatment. Okay, then write down next sub point, unsteady state heat conduction, unsteady state heat conduction, unsteady state heat conduction, unsteady state heat conduction, unsteady state heat conduction. So write down systems with negligible internal resistance, systems systems with negligible internal resistance, negligible internal resistance, comma Biot and Fourier number, Biot and Fourier number and their significance, Biot and Fourier number and their significance, and their significance, comma Biot and Fourier number and their significance, and their significance, comma lumped heat capacity analysis, lumped heat capacity analysis, lumped heat capacity analysis, lumped heat capacity analysis, bracket descriptive treatment, descriptive treatment, descriptive treatment. So this is about the syllabus for the unit number 1. So in this topic we have to cover the 3 sub points, that is modes of heat transfer, then we have to go for the steady state heat conduction, and then we have to go for the unsteady state heat conduction, unsteady state heat conduction. So today we have to start the unit number 1 with the modes of heat transfer. So write down the first point. Before going to modes of heat transfer, first of all, you have to write down the definition of heat. Write down first point. Write down definition of the heat. Write down definition of heat. So we know that heat always move from the warmer place to the cooler place. So we know that what is meant by heat. Heat is nothing but it is a energy. Heat is nothing but it is a energy which is in transient. What is the meaning of transient? It is in a continuous movement or continuous motion. What is meant by heat? Heat is nothing but heat is a energy which is in transient and which moves from one location to the another location. It moves from or which it transfers from one location to the another location. That is nothing but heat. So write down the definition of the heat. Write down. Heat is a energy. Heat is a energy. Heat is a energy which is in transient. Heat is a energy which is in transient in bracket. Write down the meaning of transient, that is continuous movement. Heat is a energy which is in transient in bracket continuous movement which transfers from one location to which transfers from one location to one location to another location one location to another location one location to the another location. So this is about the heat. So what is meant by heat? Heat is nothing but it is a energy which is in transient and which moves from the one location to another location. This is about the heat. So in this slide, some information related to heat is given. So hot objects in a cooler room will cool to room temperature. So if there is a hot object in a cooler room, then what will happen? The temperature of that particular object will be reduces. And similarly for the cold objects in a warmer room, what will happen? The temperature of that particular object will be increases. So in this way, the equilibrium will be happened. So heat transfer is takes place from the high temperature region to the low temperature region. Heat will transfers from the high temperature region to the low temperature region. So heat is a form of energy which passes from a body at higher temperature to a body at a lower temperature. So this is a cup of coffee. So coffee having temperature is 70 degrees Celsius and environment having temperature is 20 degrees Celsius. So because of this temperature difference, what will happen? The temperature of this hot coffee will be reduces. Temperature of this hot coffee will be reduces. So in this way heat transfer is takes place. In this way heat transfer is takes place. Okay, so write down the next point. Write down modes of heat transfer. Our first point is modes of heat transfer. Write down modes of heat transfer. In that, write down first conduction, second convection, and third one radiation. Write down modes of heat transfer. Modes of heat transfer. In that, first mode is conduction, second mode is convection, and third mode is a radiation. Third mode is a radiation. Okay, so basically these are the three modes of the heat transfer. Okay, so before going to these modes of heat transfer, why we need a heat transfer? So basically we have studied the one subject in second year, that is thermodynamics, and now in third year we have to learning the subject, that is heat transfer. So basically what is the difference between the thermodynamic subject and heat transfer subject? So thermodynamics simply tells us how much amount of heat transfer from one equilibrium state to the another equilibrium state. Means in the thermodynamics we have calculated the only heat. Means suppose we have to consider one object is having at one equilibrium stage, another object having one equilibrium stage. So how much heat transfer will be takes place? That calculation we have done in the thermodynamic subject. But what about the heat transfer subject? So our aim is to calculate the how much time is required. Means suppose initially one object is having temperature is 100 degrees Celsius, and after some time the temperature of that particular object becomes 50 degrees Celsius. So in the heat transfer subject we have to calculate the how much time is required to attain that particular temperature. So heat transfer is related to the rate of heat transfer and thermodynamics is only related to the amount of heat. What is the difference? We have to do the calculation in the heat transfer with respect to time. But what about the thermodynamics? We have to calculate the only heat. There is a no any information related to the time. So this is the basic difference between the thermodynamic subject and heat transfer subject. In the heat transfer subject, we have to calculating the heat means we have to calculating the values in the joule. But what about the heat transfer? Heat transfer is nothing but we have to calculate the rate of heat transfer. Means thermodynamics is dealing with the amount of heat transfer, that is joule, and heat transfer is dealing with the rate of heat transfer, that is joule per second. So that joule per second is nothing but watt. Joule per second is nothing but watt. So this is the basic difference between the thermodynamic subject and heat transfer subject. Thermodynamic subject and heat transfer subject. We have to remember that thermodynamics is nothing but related to the amount of heat, and heat transfer is related to the rate of heat transfer, that is joule per second. Joule per second. So this is about the why we need the heat transfer, because in the thermodynamics we have calculated the only heat, but in heat transfer we have to calculate the how much time is required to attain that particular temperature. For that there is a need of heat transfer subject. There is a need of heat transfer subject. Okay, then next slide. Okay, so what are the different applications where we have to use the heat transfer subject? So there are so many applications in that we have to use this heat transfer subject, because in this heat transfer we have to understood the different modes of heat transfer, that is we have to understood conduction, what is meant by convection, what is meant by radiation, then we have to go for the condensation, then we have to go for the boiling, then heat exchanger. So these are the area that we have to cover in this heat transfer subject. So what are the applications? So heat transfer plays major role. Design of many devices. What are the different devices we have to design by using this subject? So what is the basic requirement of this subject? That is we have to design by using the heat transfer subject. That is we have to design radiator, then different solar collectors are there, then various components of the power plant, then spacecraft. So these are the some refrigeration units are there, then some of the components of the power plants are there, then air conditioning systems are there, then circuit boards are there. In this all equipments heat transfer is major issue, because if we have to consider the any component and if the temperature of that particular component is continuously increases, then what will happen? The burning of that particular component is takes place. So our aim is to design that component in such a manner that the maximum heat dissipation will be takes place into the surrounding and that component will be safe. Understood? What is the need of this heat transfer subject? We have to design the different components by using this subject. We have to design the different components. So how to design that different components? By using the different equations, and in that equation we have to calculate the particular parameters, and according to parameters we have to design that particular component. If we have not designing that particular heat transfer component, what will happen? That carbon, that the life of that particular component will be less. So we have to design the component by using this heat transfer subject, so that the life of that particular component is higher. So there is a maximum requirement of the component. So for that there is a need of heat transfer subject. So by using this heat transfer subject we have to design these different components. In that components we have to considering the heat. Heat as a major parameter, and because of this what will happen? The maximum times number of components are failing because of this high temperature region. So our aim is to maintain the temperature of that particular object in a particular range, so that the life of that particular component will be increases. So this is the applications where we have to use this heat transfer subject. Means for the designing these different components we have to use this heat transfer subject. So this is about the applications where we have to use the heat transfer subject. Okay, then write down the first mode of heat transfer, that is conduction. Write down first mode of heat transfer is conduction. So before going to this point, what is the definition of the conduction, or what we have understood from this conduction? Anyone? What is the definition of conduction? Conduction means what? Anyone? Already we have discussed about the modes of heat transfer, what is meant by conduction, what is meant by convection, what is meant by radiation. So we know that intermolecular force of attraction is more in solid as compared to the liquid and gases. So from this PPT, we have to understood. So this first image is nothing but solid. Then second image is nothing but liquids, and third image is nothing but gases. So intermolecular force of attraction is more in the solid as compared to the liquid and gases, and as compared to the gases, the intermolecular force of attraction more is in the liquids. So conduction is because basically because of the lattice vibration and free electrons in the solid. Means what? In the solid, heat transfer is takes place because of the conduction. So what is the reason behind this? That is the lattice vibration and free electrons. And in the liquids, conduction is takes place because of the collision of the molecules. Collision of the molecules. Similarly, in the gases, heat conduction is takes place because of the collision of the molecules. But in the gases, intermolecular force of attraction is less. Intermolecular force of attraction is less. So all of you write down the definition of the conduction. First of all, you have to write down the definition of the conduction. So what is the definition of the conduction? Conduction is nothing but transfer of heat from one part of a substance to the another part of the same substance, or from one substance to the another substance in physical contact with or without appreciable displacement of the molecules. Without appreciable displacement of the molecules. Suppose we have to consider this is the solid component. So at this end, suppose we have to heating this component, then what will happen? First of all, these molecules will be heated, and because of that high temperature, what will happen? That molecules transferring their energy to the adjacent molecules. So heat transfer is takes place because of the physical contact. Because of the physical contact, that heat transfer is nothing but what is meant by conduction of mode of heat transfer? If one end of the object is heated, because of that molecules, whatever the molecules which is present at the one end, that molecules transferring their energy to the adjacent molecule, then that adjacent molecule transfer their energy to another adjacent molecule. So in this way, the heat transfer is takes place from the one end to the another end because of the physical contact. Because of the physical contact, that mode is nothing but conduction. That mode is nothing but conduction. So all of you write down the definition. Conduction is the conduction is the transfer of heat from conduction is the transfer of heat from one part of a substance to another part of the same substance. Conduction is the transfer of heat from one part of a substance to another part of the same substance, or or from one substance to another substance, or from one substance to another substance in in physical contact in physical contact with it in physical contact with it without appreciable displacement of molecules without appreciable displacement of molecules forming the substance forming the substance forming the substance. Understood? What is meant by conduction? Conduction is nothing but transfer of heat from one part of a substance to another part of the same substance, or from one substance to another substance in physical contact with it without appreciable displacement of molecules. Means whatever the molecules which are present in this solid. So these are the molecules which are present in the solid. the heat transfer is takes place without the appreciable displacement of these molecules. So heat transfer is takes place because of the lattice vibration and free electrons. Lattice vibration and free electrons. So this is the images where we have to understood what is the difference between the solids, liquid and gases. That is the difference is because of the intermolecular force of attraction. Okay, so this is about the conduction. Next line we have to write down in solid, in solid, in solid, the heat is conducted by the in solids the heat is conducted by the following two mechanisms. Heat is conducted by the following two mechanisms. Following two mechanisms. Write down first by lattice vibration. In solid, heat is conducted by the following two mechanisms. First one is by lattice vibration, and second by transport of free electrons. Second, by transport of free electrons, transport of free electrons. Okay, so this is about the conduction. So in the solid, it's conducted because of the lattice vibration and free electrons. What about the liquid? Heat transfer because of the collision. So write down for the liquid, for the liquid, heat conduction, heat conduction because of the collision of molecules, because of the collision of molecules, collision of molecules, collision of molecules. So in this way, the heat transfer is takes place because of the conduction. So conduction is possible in the solid, liquid and gases. So in the solid, it is conducted because of the lattice vibrations and free electrons. Then in the liquid, heat conducted is because of the collision of the molecules. Similarly, in the gases, heat is conducted because of the collision of the molecules. But the difference is the intermolecular force of attraction is less as compared to the liquid. So this is about the conduction. In the conduction, heat transfer is because of the physical contact, because of the physical contact. Then okay, so this is one object. So in this object, this is solid object. In that object, number of molecules are there. So at one end we have to heat it. Because of that, what will happen? So free electrons are gaining the energy at the one end and transferring their energy to the another end. So in this case, these molecules are fixed. The molecules are in vibratory motion. Because of this vibration, the heat transfer is takes place to the adjacent molecules, and there are some free electrons, and because of that free electrons, the energy transfer is takes place. So that is nothing but conduction. That is nothing but conduction. So why metals good thermal conductors? Because of this number of free electrons. So basically conduction is takes place due to the lattice vibration and free electrons. So 70% weightage for the free electrons and 30% weightage for the lattice vibration. So in the metals there are number of free electrons. So because of that, these metals are good thermal conductors. Understood? Why metals are good thermal conductors? Because in the metals maximum number of free electrons are there. So if the maximum number of free electrons are there, then maximum heat transfer will be takes place. So due to that, metals are good thermal conductors. Metals are good thermal conductors. So this is about the conduction. Then this is the same example. At the one end we have to heated that particular this metal rod. Then what will happen? That another end will be heated because of this conduction. Means whatever the molecules which is present at the one end that molecules gaining the energy and transferring the energy to the adjacent molecules. So in this way, heat transfer is takes place. At one end we have to heat it, and automatically another end will be automatically heated. So that mode is nothing but conduction. That mode is nothing but conduction. So this is about the first mode of heat transfer, that is nothing but conduction. Okay. Then we have to consider factors affecting the thermal conductivity. That point we have to cover the afterwards. That is the after the Fourier's law of heat conduction. Okay. Then thermal conductivity in solid. So we know that thermal conductivity is nothing but ability of material to transfer the heat. Ability of material to transfer the heat, that is nothing but thermal conductivity. So now we have to consider the thermal conductivity for the solid, then thermal conductivity for the liquid, then thermal conductivity for the gases. So if we have stir hot tea using a metal spoon, you will observe that the handle of the spoon becomes warm. So this is the example for the solid. Suppose we have to stirring the hot tea using the metal spoon, then what will happen? Automatically the handle of that particular spoon becomes warm. So this mode of heat transfer is nothing but conduction, and this conduction is takes place in the solid. That is, the heat transfer is takes place in that particular spoon because of the conduction, and due to that, that spoon handle becomes warm. So solids that are good conductors of heat use both atom vibration and free electrons to conduct heat. Then what about the liquids? So this is because there are large intermolecular distances between liquid molecules. So the thermal conductivity of solid is greater than the thermal conductivity of the liquid. What is the reason behind this? Because there are large intermolecular distances between the liquid molecules. Means intermolecular force of attraction is less in the liquid as compared to the solid. So there are also fewer and rare collision between the molecules. If number of molecules are less in the liquid, so because of that, what will happen? The fewer and rare collision between the molecules. So because of that, the thermal conductivity of solid is more than the thermal conductivity of the liquid. Understood? What is the reason behind this? The thermal conductivity of solid is more because the number of molecules are more in the solid, and the distance between the molecules is less in the solid. So because of that, the maximum heat transfer will be takes place because of the conduction in the solid is more, and in the liquid the distance between the different molecules is less, and due to that, whatever the heat transferring from one molecule to another molecule, it requires more time. So because of that, thermal conductivity of that particular solid is higher as compared to the liquid. And what about the, what is the example for that? That is electrolysis. Suppose we have to consider the salt solution are better conductors of heat than the pure liquid, because in salt solution there are the molecules of the salt, because the molecules are more in the salt solution. So because of the thermal conductivity of that salt solution is higher as compared to the pure liquid. Then what about the thermal conductivity in gases? So gases are worst conductors of heat because of large intermolecular distance. So in the liquid there are medium distance between the molecules, but what about the gases? The distance between the two molecules are higher. So whatever the heat transfer because of the conduction is takes place in the gases is less as compared to the solid and liquid, as compared to the solid and liquid. So this is about the thermal conductivity for the solid, thermal conductivity for the liquid, and thermal conductivity for the gases. So from this concept we have to understood that thermal conductivity of solid is greater than the thermal conductivity of liquid is greater than the thermal conductivity of the gases. Thermal conductivity of the gases. So this is about the thermal conductivity. Then write down next point, next mode of heat transfer, that is convection. Write down next point is second mode of heat transfer, that is convection. So what about the conduction? Heat transfer is due to the physical contact. Then what about the convection? So we know that one example, suppose we have to heating the water. At that time what will happen? Whatever the molecules which is at the bottom side, that molecules gaining the energy, and because of that heat what will happen? The density of that particular molecules will be reduces, and due to less density these molecules will come at the upper side, and whatever the high density molecules which are present at the top side, that molecules will be moving into the downward direction. So in this case heat transfer is takes place, but these molecules are moving from their one location to the another location. Means what? In the conduction heat transfer is takes place due to the motion of the molecules. In the conduction the position of the molecules is fixed, but what about the convection? Molecules gaining the energy and changing their position from one location to the another location. They are taking the heat from one location and going to the another location. So in this way heat transfer is takes place. That mode of heat transfer is nothing but convection. So in this diagram, suppose this is one object and we have given the heat to this particular object, then what will happen? The molecules, the distance between these molecules is increases, or the position of these molecules is changes. So in this way the heat transfer is takes place. So that mode of heat transfer is nothing but convection. This mode of heat transfer is nothing but convection mode of heat transfer. Okay. So what is meant by convection? Convection is nothing but transfer of heat because of the motion of molecules. So write down definition of convection. Write down definition of convection. Convection is heat transfer by convection is convection is heat transfer by heat transfer by motion of fluid. Convection is transfer of motion of fluid such as air or water, such as air or water. Full stop. Next line. Convection does not occur in solid. Convection does not occur in solid. Convection does not occur in solid because because the particles within are are tightly packed tightly packed tightly packed. Full stop. Convection requires convection requires actual movement between the particles. Convection requires actual movement between the particles within a substance within a substance within a substance within a substance. So this is about the convection. So from this PPT, see on the screen. So this is the fire. So because of the fire, whatever the air molecules which is present near to this, what will happen? These molecules will be heated, and that molecules reduces their density, and these molecules moving in the upward direction. So in this way heat transfer is takes place because molecules are gaining their energy, and because of that density will be reduced and these molecules will move in the upward direction. At the same time whatever the high density molecules will be coming towards this fire, and again the temperature of that particular molecules will be increases, then density will be reduces and that molecules will be moving in the upward direction. So in this way molecules are gaining energy and transferring their energy to the another location. Means what? The heat transfer is takes place due to the motion of the molecule. Due to the motion of the molecule. So this is about the convection. So in that convection there are two types. Write down types of convection. Next point, types of convection. Types of convection. Write down first one, natural convection. Natural convection. Types of convection. In that first one, natural convection. So basically we know that in the natural convection, heat transfer or motion of the molecules because of the density difference. Because of the density difference. But what about the forced convection? Whatever the molecules we are considering the motion for that molecules because of the external devices, means we have to using the pump, we have to using the fan, then we have to using the blower, then we have to using the external steering. So because of that we have to using the external agency for the motion of that particular molecule. So that type of convection or that type of heat transfer is because of the forced convection. But in the natural convection, we don't use any external devices. So heat transfer is takes place because of the density difference. That is nothing but natural convection. So write down natural convection. Write down from the screen. Natural convection occurs whenever heat flows between a solid and fluid. Natural convection occurs whenever heat flows between a solid and a fluid. Heat flows between a solid and a fluid or between fluid layer. Means convection is possible in the fluid. If two layers are there, then there is a possible of convection. If there is a solid and liquid layer is there, at that time there is a possible of convection, because from that solid surface heat transfer is taking towards the liquid. Okay. Then write down the forced convection. Forced convection. So mixing of hot and cold parts of the fluid. Forced convection, mixing of hot and cold parts of the fluid through some external stirring, external stirring, like a fan or pump. External stirring like a fan or pump. Like a fan or pump means in the forced convection we are using the external devices. If we have started the fan, at that time we feeling the cold, because of the efficiency of that forced convection is higher as compared to the natural convection. Efficiency of the forced convection is higher as compared to the natural convection, because we have to using the external devices in the forced convection, and because of that easy motion to that particular molecules is takes place. So this is the basic difference, natural convection and forced convection. In natural convection we don't use any external devices, and in forced convection we have to using the external devices. So that is nothing but natural convection and forced convection. Natural convection and forced convection. Write down third mode of heat transfer, that is radiation. Write down third mode of heat transfer. Third mode of heat transfer is radiation. Okay. So write down the definition of radiation. We know that what is the definition of radiation? Transfer of heat in the form of electromagnetic waves. So write down radiation is nothing but transfer of heat in the form of electromagnetic waves. Electromagnetic waves in the form of electromagnetic waves. Okay. So we have to understood what is meant by radiation. So for the conduction and convection there is a need of medium. For the conduction and convection, there is a need of medium to transfer the heat from one location to the another location. But what about the radiation? There is a no need of any medium. There is a no need of any medium. That is nothing but radiation. Means heat transfer takes place in the vacuum also. Heat transfer takes place in the vacuum also because of this radiation. Because suppose we have to consider the sun and earth. So whatever the sun rays which are coming from that particular sun towards the earth, so there is no environment in between the sun and earth. So still the heat transfer takes place from the sun to the earth because of the radiation. But for the conduction and convection, there is a need of medium to transfer the heat. Transfer the heat. So here one example is given. An electric bulb in a room produces both light and radiant heat. So the radiant heat is absorbed by the material in the room, which in turn give out radiant heat of lower energy. So this is the bulb which is radiating the energy in the form of waves. In the form of waves. So this is about the radiation, and everybody emits radiation above 0 Kelvin. Means anybody having temperature is above 0 Kelvin, that body emits the radiation. The capacity of that particular radiation is depending upon the temperature of that particular object, but everybody emits the radiation above 0 Kelvin. Okay, then radiation is a method of heat transfer that does not require any medium. So already I have told that there is no need of any medium to transfer the heat. Then it can take place in vacuum. In radiation, heat transmits energy in the form of waves. Okay, the heat energy from the sun is radiated to us. That is nothing but radiation. Okay, another example for the radiation. So the earth is warmed by heat energy from the sun. So how does this heat energy travel from the sun to the earth? So there are no particles between the sun and the earth, so the heat cannot travel by conduction or by convection. Means what? Radiation heat transfer is nothing but other than the conduction and convection, whatever the heat transfer is takes place, other than the conduction and convection, whatever the mode of heat transfer is there, that mode of heat transfer is nothing but radiation. So the heat travels to earth by the infrared waves. So these are the similar to the light waves and are able to travel through the empty spaces. So the this is the sun and this is the earth. In between these two, there is a no environment is there. There is a no medium. Still, the heat transfer takes place from the sun to the earth because of the radiation. Because of the radiation. So this is about the radiation. Okay. Then we have to go for the next point. Right on the next point, Fourier's law of heat conduction. The law which is related to the conduction, that law is nothing but Fourier's law of heat conduction. Fourier's law of heat conduction. So all of you write down the next heading, Fourier's law of heat conduction. Write down Fourier's law of heat conduction. Okay. So first of all, we have to write down the statement. Write down the statement. Fourier's law of the heat conduction. Write down Fourier's law of heat conduction. So write down the rate of flow of heat through 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 a simple homogeneous solid, a simple homogeneous solid, a simple homogeneous solid, a simple homogeneous solid is directly proportional to the is directly proportional to the is directly proportional to the area of the section area of the section area of the section area of the section at right angles to the direction of heat flow, area of the section at right angles to the direction of heat flow, heat flow, and to change of temperature, and to change of temperature with respect to the length of the path of the heat flow, length of the length of the path of the heat flow, length of the path of the heat flow. Okay, so what is meant by Fourier's law of heat conduction? Fourier's law of heat conduction: the rate of flow of heat through a simple homogeneous solid is directly proportional to the area of the section, area of the section at right angles to the direction of heat flow and to change of temperature with respect to the length. So rate of flow of heat through. What is the only heat transfer is nothing but having unit is joule. But now we are saying that rate of flow of heat through means what is the notation for that? Q. What is the notation for that? So Q is equal to sorry Q is directly proportional to area into dt by dx, area into dt by dx. So means what? Okay, so what is the Fourier's law? Heat transfer rate means Q is directly proportional to the area which is normal to the or which is right angles to the direction of heat flow. So Q is directly proportional to A, and directly proportional to the change in temperature with respect to distance, change in temperature with respect to distance. So Q is directly proportional to area and change in temperature with respect to distance. So write down Q is directly proportional to A into dt by dx, A into dt by dx. Q is directly proportional to A into dt by dx. So write down the meaning of this Q. Q is nothing but Q is equal to heat flow through a body per unit time. Heat flow through a body, heat flow through a body per unit time, per unit time, per unit time. Then capital A is equal to surface area of heat flow, surface area of heat flow, surface area of heat flow, surface area of heat flow in bracket perpendicular to direction of heat flow, in bracket perpendicular to direction of heat flow, bracket complete, perpendicular to direction of heat flow. Then dt is nothing but temperature difference of the faces of block, temperature difference, temperature difference of the faces of block, temperature difference of the faces of block. Then dx is nothing but thickness of body, thickness of body, thickness of body in the direction of flow, thickness of body in the direction of flow, in the direction of flow. Okay, suppose from the screen this is one object or this is one wall is there. So what is the thickness of this wall? That is dx. So from this left hand surface to right hand surface heat transfer will be takes place. From this left hand surface to the right hand surface heat transfer is takes place. Suppose we have to consider this left hand surface having temperature is T1 and this right hand surface is having temperature is T2. So whatever the heat flowing from this left hand surface to the right hand surface, that heat transfer rate is directly proportional to what? Area. Kutla area? Area which is right angles to the direction of heat flow, means this area, or what is the name for this area, that is area which is normal to the direction of heat flow, means this area is nothing but capital A. So heat transfer rate through this particular solid is directly proportional to area which is normal to the direction of heat flow, and change in temperature with respect to distance, means this surface is having temperature is T1 and this right hand surface is having temperature is T2. Change in temperature means what? T2 minus T1 means final temperature minus initial temperature. So T2 minus T1 divided by with respect to distance. So what is the thickness of this particular object? That is dx. So Q is directly proportional to area and change in temperature with respect to distance. So Q is equal to, what is the proportionality constant? Minus K. So what is the meaning of this minus sign? So this K is nothing but thermal conductivity. For the solid, whatever the heat transfer takes place in the form of conduction. So what is the proportionality constant? That is nothing but thermal conductivity. So whatever the Fourier statement, that is Q is directly proportional to area and change in temperature with respect to distance. So according to that, we have removing that proportionality sign and we have taken the equal to. So there is a need of proportionality constant. So what is the proportionality constant? That is thermal conductivity. But there is a need of to take the negative sign. So what is the reason? Because, so suppose we have to consider this left hand surface having temperature is T1 and right hand surface having temperature is T2. So heat transfer takes place from this left hand surface to this right hand surface. So at the time of heat transfer, the temperature will be reduced. So T1 is greater than the T2. But suppose we have continuously increases this dx. If dx is increases, then what will happen? The temperature is continuously reduces. Means whatever we are doing the calculation T2 minus T1. So T2 minus T1, T2 is less as compared to the T1. So because of that, so this dt by dx is having answer is in the negative. So our aim is to calculate the heat transfer, so that we have converted that negative into positive. For that we have to considering this is as a negative sign, because if this thickness of this particular plane wall is continuously increases, then automatically temperature will be reduces. So therefore we have to take the negative sign for that particular proportionality constant, that is minus K. Understood? What is meant by Fourier's law of heat conduction? Rate of flow of heat through, म्हणजे हा जो काही प्लेन वॉल आपण कन्सिडर केलेले आहे, त्या प्लेन वॉल मधून किती रेट मधून हीट ट्रान्सफर होणार आहे आपल्याला जर कॅल्क्युलेशन करायचं असेल तर रेट ऑफ हीट ट्रान्सफर इज डायरेक्टली प्रोपोर्शनल टू एरिया. तर कुठला एरिया? तर परपेंडिक्युलर जिथून हीट ट्रान्सफर होत्या त्या हीट ट्रान्सफरला जो काही एरिया परपेंडिक्युलर असणार आहे त्याचा एरिया म्हणजे काय असणार आहे? कॅपिटल ए असणार आहे. आणखी कशाला प्रोपोर्शनल असणार आहे? तर चेंज इन टेम्परेचर विथ रिस्पेक्ट टू डिस्टन्स, म्हणजे लेफ्ट हँड सरफेसचं काहीतरी टेम्परेचर असणार आहे आणि राईट हँड सरफेसचं काहीतरी टेम्परेचर असणार आहे. तर त्या टेम्परेचर डिफरन्स वरती पण काय असणार आहे? तुमचा रेट ऑफ हीट फ्लो डिपेंड असणार आहे. आणखी कशावरती असणार आहे? तर ह्या थिकनेस वरती. म्हणून त्याला काय म्हटलेलं आहे? dt बाय dx. इन दॅट वे ऑफ कन्सिडरिंग दी टेम्परेचर ॲज वेल ॲज थिकनेस. सो dt बाय dx इज नथिंग बट टेम्परेचर ग्रेडियंट. सो Q इज डायरेक्टली प्रोपोर्शनल टू एरिया, म्हणजे एखाद्या ऑब्जेक्ट मधून किती हीट ट्रान्सफर होणार आहे हे कशाला प्रोपोर्शनल असणार आहे? तर ज्या सरफेस मधून परपेंडिक्युलर हीट ट्रान्सफर होणार आहे तो एरिया आणि त्या दोन्ही सरफेसच्या मधला टेम्परेचर डिफरन्स विथ रिस्पेक्ट टू डिस्टन्स, ह्या दोन्हीला काय असणार आहे? तो प्रोपोर्शनल असणार आहे. याच्यावरून आपल्याला काय इक्वेशन मिळालेलं आहे? Q इज इक्वल टू K इंटू A इंटू dt बाय dx. पण जर तुमच्या प्लेन वॉलचा किंवा तुमचा कुठलाही सॉलिड ऑब्जेक्ट असेल तर त्याचा थिकनेस जर वाढत गेला तर ऑटोमॅटिकली टेम्परेचर काय होत जाणार आहे? कमी जाणार आहे. म्हणजे जर ज्यावेळेला तुम्ही dt बाय dx फाइंड आउट करणार आहे त्यावेळेला हा dt म्हणजे काय असणार आहे? फायनल टेम्परेचर मायनस इनिशियल टेम्परेचर, म्हणजे फायनल टेम्परेचर तुमचं कमी आहे. सो दिस dt बाय dx इज हॅव्हिंग आन्सर इज इन दी नेगेटिव्ह. सो So our aim is to calculate the heat transfer. So for that there is a need of positive answer. So if dt by dx is in negative, then we get the answer is in the negative. So for that, converting the answer into positive, there is a need of another negative sign. So we have given the another negative sign to that particular proportionality constant. So because of that, we get the answers in the positive sign. So what is the Fourier's equation? That is q is equal to minus k into a into dt by dx. समजले का बघा सगळ्यांना? फोरियर्स लॉ म्हणजे काय असणार आहे? एखाद्या ऑब्जेक्ट मधून किती हीट ट्रान्सफर होणार आहे हे कशाला प्रोपोर्शनल असणार आहे? तर त्याच्या एरियाला, जो एरिया नॉर्मल टू हीट फ्लो असणार आहे आणि त्याचा जो काही टेम्परेचर डिफरन्स असणार आहे विथ रिस्पेक्ट टू डिस्टन्स, ह्या दोन क्वांटिटीला हीट ट्रान्सफर रेट काय असणार आहे? प्रोपोर्शनल असणार आहे. आणि इथे प्रोपोर्शनलिटी कॉन्स्टंट आपण काय घेतलेला आहे? के घेतलेला आहे. त्याला निगेटिव्ह साइन का दिलेला आहे? जर थिकनेस वाढत गेला तर टेम्परेचर ऑटोमॅटिकली कमी होत आहे. त्यामुळे हा dt बाय dx निगेटिव्ह मध्ये येतोय. तो कन्वर्ट करायला पॉझिटिव्ह मध्ये आपण काय केलेला आहे? निगेटिव्ह साइन घेतलेला आहे. सो दिस इज दी Fourier law of heat conduction, that is q is equal to minus k into a into dt by dx, minus k into a into dt by dx. So this is about the Fourier's law of the heat conduction. So write down below this equation q is equal to minus k into a into dt by dx. K is equal to thermal conductivity of the body. Write down K is equal to thermal conductivity of the body. Thermal conductivity of the body, and below that we have to write down the negative sign of K is to take care of the negative sign of K is to take care of the decreasing temperature, take care of the decreasing temperature along with the direction of increasing thickness, along with the direction of increasing the thickness. समजले का बघा सगळ्यांना? फोरियर्स लॉ सिंपल आहे. एखाद्या ऑब्जेक्ट मधून आपल्याला जर रेट ऑफ हीट ट्रान्सफर कॅल्क्युलेट करायचा असेल तर तो रेट ऑफ हीट ट्रान्सफर कशाला प्रोपोर्शनल असणार आहे? ज्या सरफेसला आपले हीट ट्रान्सफर नॉर्मल असणार आहे त्या सरफेसचा एरिया आणि जी काही वॉलचा थिकनेस आहे त्याचं चेंज होणारं टेम्परेचर विथ रिस्पेक्ट टू थिकनेस, दॅट इज नथिंग बट dt बाय dx. तर ह्याच्यावरून आपल्याला काय इक्वेशन मिळते? Fourier's law of heat conduction q is equal to minus k into a into dt by dx. तर ह्या Fourier's law चे कुठले कुठले अझम्पशन्स असणार आहेत? कुठल्या अझम्पशन्स वरती आपल्याला इक्वेशन मिळालेलं आहे? तर आता इथं बघा, आपण एकाच डायरेक्शन मध्ये हीट ट्रान्सफर होते असं धरलेलं आहे, पण हीट ट्रान्सफर ही आपण एक्स ऍक्सिस कन्सिडर केलेला आहे. वाय डायरेक्शन मध्ये पण हीट ट्रान्सफर होणार आहे, देन झेड डायरेक्शन मध्ये पण हीट ट्रान्सफर होणार आहे. सो in this case we have considering the different assumptions, and what are that assumptions? That is conduction of heat takes place under steady state conduction. म्हणजे अनस्टेडी स्टेट कंडक्शन आपण कन्सिडर केलेलं नाही, म्हणजे सडन त्याच्यामध्ये टेम्परेचर मध्ये चेंज होणार नाही. एखाद्या पर्टिक्युलर पॉईंटचं जरी टेम्परेचर असणार आहे त्या टेम्परेचर डज नॉट चेंजेस विथ रिस्पेक्ट टू टाइम. त्याच्यानंतर जी काही हीट फ्लो असणार आहे तो एका डायरेक्शन मध्येच होणार आहे. त्याच्यानंतर टेम्परेचर ग्रेडियंट जो असणार आहे म्हणजे हा dt बाय dx ची जी काही व्हॅल्यू असणार आहे ती कॉन्स्टंट असणार आहे असं आपण अज्युम करणार आहे. देन इंटरनल हीट जनरेशन मध्ये एखादा जर ऑब्जेक्ट असेल तर त्याच्यामध्ये इंटरनल हीट जनरेशन जे असणार आहे ते आपण झिरो कन्सिडर करणार आहे, कारण जर त्याच्या ऑब्जेक्टच्या आतमध्ये जर हीट जनरेट होत असेल तर आपलं हे इक्वेशन त्याच्यासाठी सुटेबल नसणार आहे. देन बाउंड्री सरफेस जे असणार आहे ते आयसोथर्मल असणार आहे आणि मटेरियल जे असणार आहे ते आपण होमोजिनियस आणि आयसोट्रॉपिक कन्सिडर करणार आहे. म्हणजे हे जे इक्वेशन डिराईव्ह केलेलं आहे त्याच्यासाठी कुठले कुठले अझम्पशन्स आहेत? तर हीट ट्रान्सफर जे असणार आहे ते एका डायरेक्शन मध्ये होणार आहे. Then conduction is takes place under steady state heat transfer. Then temperature gradient is constant. Then internal heat generation is zero. So on this assumption, this Fourier's law is depends. This Fourier's law is depends. So in tomorrow's lecture, we have to solve the problems on this Fourier's law of heat conduction. समजले का? ही जी काही इक्वेशन बघितलेले आपण q is equal to minus k into a into dt by dx, याच्यावरती आपण काय करणार आहे उद्याच्या लेक्चर मध्ये एक थोडेसे प्रॉब्लेम सॉल्व्ह करणार आहे. सो दिस इज अबाउट दी first point, that is we have covered, that is modes of heat transfer, and we have started the Fourier's law of the heat conduction. Okay, so thank you very much. Remaining part we have to cover in the tomorrow's lecture. So all of you put your roll numbers in the chat box.